We are moving on here to looking at paired samples for two means. So we are still looking at the case where we have two groups, but in this case what's happening is those groups are actually not independent of one another, because what we're doing is we're looking at collecting data on the same variable of interest for the same individuals, but doing that twice. And you might wonder why we would do that. Usually the cases where we're going to use what's called a matched pairs test, which is what we're learning here. Usually that is going to be in the case where we have like a pre-test and a post-test. So maybe we're looking at student scores as a pre-test and a post-test, or maybe we're measuring something before a treatment is imposed and then measuring it again on the same individuals after we impose some treatment, and we're looking for a difference. So this is going to be called a matched pairs test. And the data for a matched pairs test is going to be the differences between the before and the after for each individual. So this ends up actually being just a one sample t-test that we learned back in chapter 7. But I'm going to show you the process of how we would find those before and after differences and what the test would look like. So we're going to use this little subscript here of a lowercase d. That just means we're looking at differences, so differences between before and after, rather than a single individual value. So the null hypothesis here is going to be that the mean difference, and again, the differences are calculated by taking the before and the after and taking the difference between those two. If the mean difference is 0, that would imply that there's no difference before or after, or pre-test or post-test, okay? The alternatives to choose from are the standard 3 that you would expect. We can test that the mean difference is just not 0, which is two-tailed. We can test that the mean difference is greater than 0, which is right-tailed. Or we could test that that mean difference is less than 0, which is left-tailed. And the alternative that we choose is going to be based on our data and what question we're trying to answer. So we need to get down here to the test statistic. I mentioned before, this is just the same as a one sample t-test. So our test statistic is going to be a t-test statistic where we're looking at all of the differences for each individual, and then we're going to take the mean of those. And we're going to look at that difference compared to the mean difference that we're expecting. And then we're going to divide by the standard deviation of the differences over the square root of the sample size. Okay, and so like I mentioned before, this is really just a test for a t-test here for one sample. So we're going to move into an example. And in this example, it says a politician asked his staff to determine whether the underemployment rate in the Northeast decreased from 2011 to 2012. And we want to test that claim at the 5% significance level. And so we have some northeastern states, and for each state we have the underemployment rate in 2011 and again in 2012. So what I want us to think about here is the direction that we're going to set this up. So let's start here with a first step for our hypothesis test, which would again be stating our significance level. We were given 0.05 for this case. And then step 2 is we have to state our hypotheses. And so our null hypothesis is going to be that the mean difference in those underemployment rates is 0. And then we have to think about the direction of the alternative. So it said that it wanted us to test whether the underemployment rate in the Northeast decreased. If it's decreasing, that means that that 2012 value, when we find the difference between the 2012 underemployment rate and the 2011, so take 2012 and subtract the 2011, if it is decreasing, that means that rate is going to be negative. So we're looking to see if the mean difference is less than 0. So if underemployment decreased, that 2012 minus 2011 is negative, and that's what we're looking for, is to see if it decreased. Okay. We are doing a t-test for one population mean, okay? But in order to do that, we need data, and you'll notice this is, in this case, we aren't given all these differences. We actually have to find them ourselves. And so I've gone ahead and we're taking 2012 underemployment and subtracting 2011. I've gone ahead and found those already. So we have negative 0.9, negative 3.7, negative 3.2, negative 0.5, positive 0.6, so that one actually went up, negative 1.9, negative 0.5, positive 0.2, positive 0.6, positive 0.4, a positive 1.7, a negative 2.4, and a positive 1.8. Again, we're finding the differences. So each one of those there, each one of those are our x sub d values, the differences for that particular x value, the differences in the underemployment rate. So what we're going to have to do is we're going to enter all of these into the calculator. Okay, so we're going to turn the calculator on, and we need to enter this as a list into the calculator. So we're going to hit Stat, Edit. We're scrolling up with our arrow keys to L1 and clearing that list by hitting Clear, Enter. And then we're entering in these differences. So negative 0.9. So we've got negative 0.9, we've got negative 3.7, negative 3.2, negative 0.5, positive 0.6, negative 1.9, negative 0.5, positive 0.2, positive 0.6, positive 0.4, 1.7, negative 2.4, and 1.8. So once you have those data values entered in, we're going to stat calculate, and under one var stats, hitting enter. And what we're trying to get is the mean and the standard deviation of those differences. So this x bar that it's giving us of negative 0.6, that is the mean difference. So that is the mean of all of those differences. So that was negative 0.6. And then right here under standard deviation, that is the standard deviation of the differences. That is 1.7. We'll take several decimal places, 1.755. Let's do one more. So 1.755, it'd be 5 if we rounded to 4 decimal places. Okay. So from there, we could do this by hand, but I mentioned we're going to go ahead and do this in the calculator. So step 3 is we're calculating that test statistic. We are going to stat. We are scrolling over to tests, and we're just doing a regular old t-test. We are going to enter in our summary statistics. So we are testing that that mean difference is 0. It's right here. We got a mean difference for a sample mean difference of -0.6 and a standard deviation of 1.7554, etc. You'll notice it pulled those in from our list. It has our sample size, and we are doing a left-tailed alternative, so we need to change that to less than. And go ahead and scroll down to calculate, and you get a test statistic T of -1.23 and a p-value of 0.1207. Okay, we would in step 5 compare that p-value to our alpha. This p-value is not less than our alpha value. Our p-value is greater than alpha, which means we do not reject the null. And so that was step 5 and 6. And so step 7 is our conclusion. And we would state here at the 5% significance level, the data does not, right, we did not reject, so the data does not provide sufficient evidence to conclude the underemployment rate in the Northeast decreased from 2011 to 2012. Okay, so even though we got a negative sample mean difference, what we're saying is that is not statistically significant enough to show that there really is a decrease.